Hey everybody! In this video we are going to go over how to divide and multiply rationals. We're going to do an example of just regular, fractions that we know and love, and then we're going to kind of turn it up a little bit piece by piece. So we're going to do kind of regular fraction stuff. How did we multiply and divide those? And then how can we apply those concepts now to if I have a linear over linear or a general polynomial over a general polynomial, and I want to multiply or divide this with any other rational, right? And how do we do that? And what's the thing that we can do every single time that will work for all of these? So that's what we're going to do. So let's go over how to do it. And it's not actually any different than what you already know how to do with fractions. The key thing here to recall is that dividing is equivalent to multiplying by the reciprocal. Now this just isn't true in like fraction and rational land. This is true always. Division is just the inverse of multiplication, which means you can just multiply by the reciprocal instead of dividing. This is true always everywhere, okay? So if you're dividing, you have to multiply by the reciprocal first. So what that means is take the second term, flip it, and change it to multiply. So what does it mean to multiply by the reciprocal? Flip it, multiply it, flip it, multiply it, flip it, multiply it. So if you're dividing, take the second term, flip it, multiply it. And then, once we got everything now into multiply land, we're going to factor all the numerators and the denominators. Why are we going to do this? Because we're going to simplify by reducing like factors between the numerators and denominators. So we multiply two fractions together. We basically just extend the fraction bar all the way across, and we like slam this fraction into that fraction, and now we have to simplify it. So we basically slam the fractions together. Now simplify. That's kind of what the operation of multiplying is. It's like, let's slam it together and see what happens. And then once we simplify it, then we'll multiply the numerator with the numerator and the denominator with the denominator, and then we'll be done. So let's see what this looks like in actual practice instead of words. So here's the 4 examples we're going to go over, and as you can see, one kind of steps up every level. We're going to do a mix of multiplying and dividing. We're going to look at a couple of different representations of division as well, just to kind of cement home, hey, division is division no matter how it looks, right? Fraction bars are just division. The division symbol is also division. So pause the video right now, see if you can do these 4 based off of the instructions. So go ahead, pause the video, try these. Alright, hopefully you paused the video, hopefully you gave these a try. Now let's go over them. So if I have 5/7 divided by 2/3, what's my step 1? Well, if I'm dividing by a fraction is the same as multiplying by the reciprocal, right? Except for that's not the reciprocal. That's the reciprocal. Okay, so reciprocal, take it and flip it. Only the second term. Leave the first term alone. So 5/7 times 3/2 now. Multiply, we go straight across the top, straight across the bottom. So this will be 15 over 14. And then there's nothing we can do here to reduce or simplify. So we're done. That's it. Right? We're going to do the same thing now. We're just going to add in some variables, and we're going to look at some higher level polynomials. But the process is all going to be the same. So now let's look at some linears. So 3x plus 21 over 2x plus 12. So I got 2 binomials here multiplied by 2 over 3x. Well, multiplying is actually, like I said, we're just going to like slam these together. So I'm just going to put that fraction bar all the way across. And we essentially just have one fraction, right? If I multiply straight across the top and straight across the bottom, boom, I would get this. So now my second step, and this is our second or third step, we're going to factor everything. So I'm going to factor 3x plus 21. I can pull a 3 out of there. That'll be x plus 7. And then this is all times 2. So let me write these all look like factors. Okay, that's my numerator. My denominator, 2x plus 12. I can pull 2 out of there. X plus 6. And then 3x. I can pull a 3 out of there. And an x. So there's everything totally factored. Now let's knock out our common factors. So 3's by 2's I can get rid of. But that's, I can really get rid of them. But that's it. So I'm left in the numerator with an x plus 7. And at this point the parentheses are no longer needed. In the denominator it looks like I'm left with an x times x plus 6. And done. So multiplying or dividing is kind of just a giant exercise in simplifying, right? Because the multiplication process for rationals is basically, hey, let's slam them all together in one giant like multiplication soup. But once we do that, we need to simplify. Since now we have all these factors floating around, we need to reduce. So multiplying and dividing polynomials is basically a giant exercise in simplifying rationals. Sorry, I said polynomials, I meant to say rationals. Alright, next example. So this is a division. So these fraction bars, these mean divide. So another way to write this is x plus 2 over x squared minus 9 divided by 1 over x minus 3. Okay? This is x plus 2 divided by x squared minus 9. This is 1 divided by x minus 3. The fraction bar just means divide, okay? It's just a notation. The fraction bar and the division symbol, they mean the same thing. So you can rewrite it if it makes you a little more comfortable. Since we're dividing, first thing we got to do, let's get rid of our division. Dividing by a fraction is the same thing as multiplying by its reciprocal. In other words, flip it over, and now we're going to multiply it. Okay, and now, since we're multiplying, so now we have just basically one big fraction bar. There's one factor, there's one factor, one factor, one factor. Let's factor everything. Well, x plus 2, x minus 3 is already factored. X squared minus 9, hey, that's a difference of squares, so that's x plus 3, x minus 3. And 1, anything times 1 is itself, so we could basically just like poof that away. And let's see, what are common factors? Now that everything's factored out, oh, I can get rid of this x minus 3, but everything else got to stay. So our resulting rational will be x plus 2 over x plus 3. And remember, we cannot cancel out these x's because we are not in a factored form. You can only cancel stuff when we're in a factored form. Addition and subtraction is not factored form. Factored forms deal with multiplication. Like these two things are in factored form, which is why we cancel out the whole factor. We can't just go over and be like, well, there's an x and there's an x. I'm going to cancel it out. We'll blow the equivalency on the rational, so we can't do that. So we're done here. So again, dividing is the same thing as multiplying by its reciprocal. Slam the whole thing together, and then factor it, simplify it, and done. Alright, let's look at this big old mess of a rational before we get to the end screen. So this big old mess of a rational. So what I'm going to do here, before I slam everything together, just for kind of ease of visual, I'm going to factor. So what I'm going to do first is I'm going to factor everything. Because I really want to get a sense of what I'm looking at here. Because there's so much stuff floating around. Maybe I can factor it first. Maybe I can reduce some stuff first before I really get into like slamming all this stuff together. So whenever you're like, wow, there's a lot of stuff here, put it in its factored form because that makes everything a lot easier to deal with, easier to look at. So this numerator here, x squared minus 25, that's a difference in squares. So that'll be x plus 5, x minus 5. The rationals is, everything in rationals is like a giant exercise in how good are you at factoring. X squared looks like it's the common factor here. If I pull x squared out, that'll give me x plus 7. Okay, no common factors to reduce here. Okay, let's try the other rational. Let's see, this is a trinomial, but I also know that there is a common factor, right? There's an x cubed that I can pull out of every term. So let me take that out of everybody. And they're all even, so I'm also going to take a 2 out. So if I take a 2x cubed, I'll be left with x squared. If I take a 2 out of 18, I'll be left with 9. If I take an x cubed out of x to the 4th, I'll be left with x. 28, if I take a 2 out, I'll be left with 14. X cubed out of x cubed, that'll give me 1. Okay. And then x squared plus 7x plus 10, that factors x plus 5, x plus 2. Alright. This guy here looks like it can be factored even further. So let me rewrite this again. X plus 5, x minus 5, x squared, x plus 7, okay, times 2x cubed. Alright, factors of 14, 7, and 2, those will add to 9, so this will be x plus 7, this will be x plus 2, over x plus 5, x plus 2. So I haven't really done any rational work yet. I've literally just been doing factoring. Alright, now step 2. Let's cancel common factors. So now remember, this fraction bar is basically, I put this in parentheses. Actually, the 2 is its own factor, the x cubed is its own factor. Multiplying fraction, basically slam it all together. So now let's look for common stuff. X plus 5s. Is there an x minus 5 anywhere? No. Is there a 2? No. There's an x factor. There's 3 up here. There's 2 down here. So I will be left with 1x. Okay. What else? Oh, an x plus 7 can go. And an x plus 2 can also go. Are those all my common factors? It looks like it. So let's see who made it out of all that. X plus 5 survived in the numerator. Sorry, that's x minus 5. What else made it out of the numerator? A 2 made it out of the numerator. Let me erase some stuff here. A 2 made it out of the numerator, and the x made it out of the numerator. Anybody else survive? No? The denominator got completely knocked out, so this is all over 1, but we never ever write it over 1. So this whole thing reduced to 2x times x minus 5. We don't need the 1 in the denominator. We need the ones in the numerator, we don't need the ones in the denominator. Anything divided by 1 in itself, right? So 2x times x minus 5 divided by 1 is still 2x times x minus 5. And this guy is done. Sweet. Alright, so if you're dividing, flip it. Multiply by its reciprocal. Only the second term. Leave the first term alone. Then factor everything as far as the eye can see. Factor the whole thing. And then after you have everything factored, remember multiplying fractions, you basically just slam the whole thing together. Slam the whole thing together. Get rid of all of the common factors that you see, and then rewrite the resulting polynomial. The resulting rational. Rewrite the resulting rational, and then you're done. So that's multiplying and dividing. So I hope you guys learned something out of this video. I hope it was helpful. Again, dividing by a fraction is the same as multiplying by the reciprocal. Dividing by a fraction is the same as multiplying by the reciprocal. Multiplying two rationals together, slam the numerators together, slam the denominators together, factor everything, cancel out common factors, and done. Multiplying and dividing rationals is basically an exercise in simplifying rationals. It's also going to use all of your factor skills that you guys have. So I hope you guys enjoyed this video, and as always, if you guys have questions, please don't hesitate to ask.